Welcome! In this lesson, we will learn the conditions for functions to have a real domain and a real range, and we will also talk about indeterminate forms. First, let's recall what domain and range mean. The domain is the set of all x values we can plug into the function. The range is the set of all y values the function can output. Now, let's list the most common rules that restrict the domain for real-valued functions. We need to watch for three big things: division by zero, even roots of negative numbers, and logarithms of non-positive numbers. Example 1. F of x equals square root of 5 minus 2x. For a square root to be real, the inside must be greater than or equal to 0. So we solve 5 minus 2x greater than or equal to 0. This gives x less than or equal to 2.5. Let's show that on a number line. Example 2. G of x equals x plus 1 over x minus 3. The denominator cannot be 0, so x cannot be 3. That means the domain is all real numbers except 3. Example 3. H of x equals natural log of 2x minus 1. For a logarithm to be real, the input must be greater than 0. So 2x minus 1 is greater than 0. This gives x greater than 1/2. Now let's discuss range. The range is about which y values the function can output. Consider y equals 1 over x minus 3. If we solve for x, we get x equals 3 plus 1 over y. That only works when y is not 0. So the range is all real numbers except 0. Now, let's talk about indeterminate forms. These come up mainly in limits. Common indeterminate forms include 0 over 0 and infinity over infinity. They do not mean the function is defined. Instead, they tell us to simplify or use limits. Here is a classic example. Consider f of x equals x squared minus 1 over x minus 1. If we plug in x equals 1, we get 0 over 0, which is indeterminate, but we can simplify. The numerator factors into x minus 1 times x plus 1, so the function simplifies to x plus 1, but only for x not equal to 1. So the big idea is this: for real domain and range, avoid illegal operations. Indeterminate forms are a signal to simplify or use limits, not to plug in directly. Once we apply the rules carefully, we can find the correct domain and range for any function.